All right, so for Unit 3, we're going to be talking about polynomials. Today, before we learn any major new stuff, we're just going to go over a lot of terminology. This could be really important for the entire unit. Some of it will be review, some of it will be a little different. All right, let's go through it. First is variable. It's basically a letter that represents a number. We're going to be dealing with it in different situations. We've dealt with these before in different units, but like X, Y, P, any letter can represent a number in a situation. So you're going to have stuff like for P, that really means 4 times some kind of number that you're not sure what it is. It's just represented by the letter P. Algebraic expressions and equations are different. A lot of the time we've been dealing with equations, which means you have something like 3x equals 12. Okay, and in this situation, you can figure out, oh, x is actually 4. This is called an equation because there's an equal sign. A lot of the stuff we're going to deal with this unit, at least at the start, is going to be an expression. So you notice when you're given the information, there's no equal sign. It's kind of like 1/2 of a question. It could say equals 10, then it would be an equation, but it doesn't have that. It's just a bunch of terms listed. You can still simplify it. A lot of times you can put things together, but there's no equals. So when we solve questions, we can't do like, oh, -4 to both sides, because there are no both sides. There's only one side. Polynomials is the core of this unit. Polynomials means basically a bunch of terms together, okay? We're going to go in more depth of what that means, but these are some examples of what like polynomials look like. So you can have like 3x added with 4, or you can have like a bunch of things added and subtracted. Exponents are okay. The thing you cannot have for polynomials is x on the denominator. Notice when we did that, that was an expression. This is an expression, but it's not a polynomial because we have x on the denominator. You can do stuff with x in denominator, and you're going to in grade 12, and it gets really weird. For now, we're going to stick with basics, no x in denominator. All right, knowing how many terms are in an expression is really, really important because it'll make the polynomials act different. Basically, the way that you can tell is when you're looking at a simplified math equation, a math expression, wherever pluses and minuses are, separate the terms. Okay, so if I wrote 3, that's a term. If I write 3x, okay, there's no pluses or minuses, they're multiplied together. That's still one term. If I write 3x, y, z, p, all of that, that's all multiplied together. That's still one term. But as soon as I do this, now it's 2 terms. Okay, because it's separated by a plus. So that's the key thing to looking for, is just those pluses and minuses. So in this first example, we can see it's 2 added together. The second one is subtracted, that's again 2. Even though there's division going on, remember, not addition, subtraction, it's still the same term. So 2. And then here, 10 plus 3 looks like it's 2, but you actually have to simplify it first because these two can go together and actually turn into 13, which is really one term. So you always have to have a fully simplified math expression, which we're going to go into in a bit. So we said polynomial was just a bunch of terms, and it's true. So technically all the stuff I have written on the page and all the stuff we looked at are polynomials. Polynomial just means like a number of terms together, okay? But there's special words we're going to be using as well. Monomial means one term. So 2x, y squared, 10. Those are all one term. They're all monomials, monocle. When I think of monomial, I think of like mono y mono, one-on-one, or like monocle, one eye, okay? Mono means one. Binomial, okay? Like bicycle or bisexual, okay? Bi means 2, so it's 2 terms. So here we have 2x plus 3, y squared minus y, 10 plus x. All of these are 2 terms. Trinomial, like tricycle or triangle, means 3. Okay, trinomial means 3 terms, so you can see these all have 3, separated by the pluses and minuses, 1, 2, 3 terms. A polynomial can be anything more than that. So if I had like x cubed plus y minus 4p plus 10, this is 1, 2, 3, 4 terms, so it's a polynomial. We don't really use words for bigger than 3, okay? But a polynomial is also just 3x. Polynomial means any number, so it doesn't necessarily have to mean that it's big. Degree is a thing that's not really important right now. It's going to be really important in grade 12 when you do pre-calc, but we still need to know what it means. So basically the way degree works is when you're looking at exponents. You look for the biggest exponent, okay, the biggest exponent in a polynomial. That number is your degree. So for example, in this one, the biggest exponent is 2, so the degree is 2. In this one term has has two exponents. There's a 2 and a 3, and they're both part of one term. You actually add those together, so the degree is going to be 5. In this one, okay, there were two terms. I can ignore this one because it has a small exponent, so I'm going to look at this one, and again, add those together gives me 5. If I look at this one, okay, the biggest one is this. Even though it's negative, it still has the biggest exponent, so it's going to be 5. And then if we look at this one's kind of a trick. There's actually a 0, right? 10 to the power of 0 here, so the degree is 0. Again, degree, the only thing really you need to know is what is the degree when given a polynomial expression. A constant is a math word for the number in a polynomial that's by itself. So x squared plus 3, this 3 has no x's, y's, no variables. The 3 is the constant. In this one, be careful, it's negative 5, not just 5. The positive negative matters too. If I do something like this, x squared plus 2x, okay, the constant is plus 0, because there was nothing at the end. The order you write polynomials is important. It goes from biggest to smallest degree. So like x squared has a degree 2, y has a degree 1, 10 has a degree 0. So that's the order it goes in. It's correct. This one over here is wrong because we had the cubed in the middle. It should have been first, then squared, then 3. So we have 3, 2, 0. Good. If there's a tie, so if it's like x squared plus y squared plus 3, usually it goes alphabetical order. So like we have x with degree 2, y with a degree 2, and then 0. That is fine. Algebra tiles, it could be really important for when we actually do questions and represent what polynomials mean. For now, you just need to know what these blocks mean. So there's a little square, a big rectangle, and then a big square. The idea with this little square represents 1 by 1. So the area of this square would be 1 times 1. It's 1. This rectangle, the width is 1, like 1 centimeter, whatever, and this width is unknown. It's x. So if we did 1 times x, that gives us x. This square has a side length of x and x. X times x gives us x squared. So we can represent these different parts of polynomial expressions using these boxes. And then the other thing is colored is positive and blank is negative. So for example, if I wanted to do 2x squared plus 3, the way I would draw that, I have two of the big colored in ones. Actually, let's do minus 3. So that would be, and then we'd have 3 little onesies. Okay, so the 3 became that, the 2x squared was that, and the whole thing together is that. It's not hard, you just need to remember what each of the 3 shapes mean. And then technically, if you're doing other weird questions, it can become, you can do like other sizes. So if that was x, like this could be y or something, but that doesn't happen very often. This we're going to get into more often, but the idea is if we're subtracting binomials, so see how we're doing 3x plus 2 minus x minus 3. That means this entire thing is getting subtracted. So it's kind of like we have 3x plus 2, okay, colored in, and then we're doing minus x minus 3. Because we're minusing everything in this box, it all has to become negative. So it'll be negative x, and then the double negative on the minus 3 makes it plus 3. Okay, so if we have these two put together, the positive and the negative cancel each other out, and we're left with 2 x's, and then 1, 2, 3, 4, 5 little ones. Don't worry, if you're not a fan of the algebra tiles, we're going to do other stuff after without the algebra tiles, okay? I did it here using like algebra. So basically the positive became negatives and minus minus becomes plus. The last thing is a review from last year, and probably the most important is collecting like terms. The idea that when you're given a math sentence, or sorry, a math expression, so all of these are expressions, some of the stuff can be put together. So if you have 3x and 2x, that's basically like we said, right? Those are x's, There's 3 of them. And then here we have 2 more x's. If we put them together, well, we have 5 x's. So we can write it as 5x. But if we say x squared plus 2x, that's this plus this. X squared is the big square, and then x, the 2 little skinny ones. These can't combine because they're different sizes. They don't fit at all. So we just leave it the same. Same thing, x plus y, they're going to be different sizes. This is going to be x, and this is going to be y. They can't go together, so it just stays x plus y. This last one, let's do together. Okay. So we have 3x squared plus 2x minus x squared plus 10x minus 3. So I like to draw boxes over them so I can see them. So 3x squared and negative x squared need to go together. I kept that negative sign. So 3x squared minus 2x squared. It's going to leave me with just 2x squared. Then we have 2x, and I can do it like right here. And then this 10x, those are both x's. They go together. They're positive. It's going to give me 12x. And then I just had this minus 3 left over. Careful, even if it doesn't match with anything, it still needs to move down. So we did these ones, we did these ones, and then now we did this one. And this is the simplified answer, the simplified expression. That's it. That was a lot of stuff really fast, but most of it wasn't skills. It was just knowing what words mean. Next day, we're going to start learning about different skills and what we have to do with those.